So in this problem, we're given that A is less than 0 and B and C are both positive. So on the number line, what this means is B is to the right of 0 and A is to the left. I'll start with A, and when I see inequality like this, I notice that there is a common term A on both sides. I'm going to factor that, and so we need to assess whether this is true or not. Now A is negative and B minus C is negative because B is less than C, so this product will be positive, so that holds true. So A is out. If I look at B, A squared less than B squared less than C squared. So here the key thing is that if A is far enough, meaning it's a negative number, but if it has a large magnitude, then if I square it, it may not be less than B squared and C squared. So for example, if A is minus 4, B is 1, and C is 2, this would be 16, which is not less than 1 squared, less than 2 squared. So the answer is B. So we don't have to technically do the remaining ones, but I'll do it for completeness here. This has to hold true because A cube is negative. Both B cube and C cube will be positive. And because B is less than C, that would still hold true. So again, C is out. Then for D, which is I think is the harder one of all of them, I'll do it in pieces. So we want to assess this. Again, I subtract. So all of these techniques that I'm using will be applicable to other problems as well, inequalities that you might see on this exam. So B is positive. B minus A is also positive because B is to the right of A. And then finally BC, we need to assess this. Again, I factor B. B is positive. Again, C minus B is positive because C is greater than B. So that also holds true. So D is out. And then finally, A squared B less than A squared C. Now here, I can divide both sides by A squared because I know for sure A squared is positive, and we are given this condition. So that also holds true, which means that's out. So the answer is, to recap, is B.